Folks, so last lesson before Easter, we're going to just go through the homework very quickly, so go down through it with me as we do it. For question 1, which was the least energy output, useful or wasted? So you can see by the size of the arrows, without even looking at the numbers and comparing them to the input, it was the useful energy was the least energy output. The percentage efficiency was the 30 divided by the 100, which gave us 30%, so this power station not very energy efficient. We had this solar cell and we had to draw a diagram using the data given. So we had 80 input, we had 10 useful, so for our output it was going to be 80 take away 10, which was going to be 70. So you had to draw your Sankey diagram. In my diagram I made one box equal to 10 joules, so I had 8 boxes up. For my wasted was 7 boxes wide and my useful was 1 box wide. And I put in my labels at the end, so make sure you have all of those. The percentage efficiency then was 10 joules divided by 80, which was 12.5%. So again, not very good on its energy output. I apologize if I might have mixed up the order of the questions. Here we had to look at bulb A and bulb B, and you had to make the decision which was more efficient, and the only way you can do that is the maths. So when we do the maths, it turns out that it is B. So that's answering the question which, and the explanation of your answer is the working out of your maths. So for bulb A, it was 9% useful output divided by 100, which was the input. Turn that into a percentage, gave us 9%. And for bulb B, it was 25% useful divided by 100 input, gave us 25% efficient. So bulb B is efficient. So that's the explanation in this instance, is using the maths. You then had to draw a Sankey diagram. So again, you are picking your scale. You did your input, you did your output or your wasted, you did your useful, and then you do your labels. So you need to make sure you have all of those things. So I was doing one box was 10 joules. So I have 10 boxes down here, 9.1 box across and 0.9 boxes this way, and have my labels in there. Similarly, one box was 10 joules here. So 10 boxes down, 7.5 across and 2.5 wide, and again have your labels. So in this question you had to do the calculations. So when you did the percent efficiency for each one, it was 14% for our torch, 30% for our car engine, 83% for the hairdryer, 61% for the video game, and 80% for the television. And when you put them in order of increasing, it should have been torch, engine, video game, TV, and hairdryer being the most efficient. In our last question then, it was just using the calculation. So you did a calculation for your filament, which was 10%, 10 over 100, which was 10%, and you did 75 over 100 for the CFL lamp, and that was 75%. So hopefully now you're happy with those. So today's, you have to design, build, and test a device that transforms energy from one source to another. It has to have a job, so that's that with the function, and you have to describe the energy changes, so know what the input is, the useful output, and the wasted output. And when we're done, describe ways to improve the efficiency of your design. So this is usually really, really fun. For today, you're going to design and build your device. We'll talk about the job, and you have to identify what are the energy inputs and outputs in this particular device. Now, you can come up with whatever you want yourself. I don't mind in the least bit, but I like to do this where we all make the same type of device, because then we can have a bit of fun and a little bit of competition. So, as I say, you can come up with your own. I have no issues. This would be my suggestion, that we build a mobile vehicle that can travel horizontally on a flat track. So that's going to be on my desk. It has to travel in a straight line on the desks in school, and you have a choice. It can be self-propelled, or we can use one of the fans in school to drive it forward. So this might be some of the ideas that you might have for making like your devices. So obviously it's going to have a wheel, it's going to have some type of base. This is obviously one that's going to be self-propelled. It's going to use a balloon. Versus over here, these are just some other ideas, and these ones here on this right hand side would end up making something that might look like this. Now, usually I might put a bit of constraint on it, but I'm not going to this year. I'm going to let you decide what it is you want to make. in terms of the dimensions of your base and your wheels and whatever it is you're using to propel it. So if you're making sails or wind turbines or whatever it is. So if we all make the same thing, we will test our device by working out how long does it take to travel down 2 meters. And we're going to add a little bit of maths and proper kind of engineering maths to this to get greater information from our device. Obviously we will have 2 categories. If you decide you're doing self-propelled, so you're going to use something that's going to make it move forward, then that is fine, versus not self-propelled, so we'll call this fan driven. So we'll use some of the fans at the back to drive them. And once we've made our device and you've done your bit of testing yourself, we will have a competition and we can figure out which device is the kind of most efficient, because usually the most efficient is the fastest. This might be just an idea for some of the equipment you might need. So coffee stirrers, they work as axles, so I'm not Starbucks type of person, so I would never have coffee stirrers, but something equivalent. So this might be your base here, and you can put your coffee stirrer, attach it to the bottom, and it will hold your wheels then on either side. You can use whatever it is you want for wheels. This is a US thing. They're really hard sweets, kind of flavored candies, but they're really, really hard. They're like Polo Mints, so they don't really break, but you just have to come up with 4 things that look like wheels. It may be that you would use beads on either side of your wheel to kind of hold it in place on your coffee stirrer, so that's what this is about. You need to make a base for yourself, and I'm not going to keep these dimensions. You can make it whatever size you want, but all I can say is once you've added size, you're adding mass, and sometimes that can slow it down, so light is sometimes better. Corrugated cardboard can be good. If you look at the corrugated cardboard sideways, it has a layer on top, a layer on the bottom, but you could actually put your axle through the little holes in your corrugated cardboard, so that may help you in your design and in keeping your axle staying in the same place. So that's what this line is here when it's saying make sure you orientate your cardboard so the inner channels run parallel. You have a choice of whatever you want for your mast material, so it might be ice lolly sticks, it could be wooden skewers, you may come up with something else. If you're going to do the fan driven or even the self-propelled, you can use a variety of things. I'll leave it up to your imagination. Aluminium foil, it might be tissue, it might be flashcards, you can use your balloons, whatever you decide yourself in terms of your sail material. So I'm really looking forward to seeing what it is you're going to actually come up with. In terms of what you have to do before we see each other in school, because you're going to be building, this is going to turn into a little report by the time we're done. And at the moment I'm considering, I think we're going to go 25% of this is going to be your summer paper. So we'll see how we get on. So your job for today's lesson is come up with your design diagram and what are your materials and your dimensions of your wheels. So what would be the diameter of your wheels? If your base, what is its dimensions? So you can just put that in your drawing. If you decided this was your base, you can give me the numbers, what they are. So you might have your wheel and you might have a diameter in here, and you'll have your number, and then you might have your design. And obviously this is not my design, but you then have, that will be your design diagram, and you'd have your list of materials, and you would have your, if you need to give me dimensions, then this is a really quick, easy way to do your dimensions. The job of your device, so for building a mobile device to travel 2 meters, well then that's going to be your job. The energy transfers you're going to have to figure out yourself. So what's going to be the source of energy, what is the useful outputs, and what might be the wasted outputs that might be in there. So you need to have a think about those. I'd like to know how your build went. So easy, hard, sometimes it can be issues with glue guns and trying to keep wheels on and blah 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 blah. So let me know how your build went, and in case your device doesn't make it into school, I would like a photo of your device, and the photo has to have you in it. It's like proof of life. Okay, as opposed to taking a photo of something off the internet. Okay, you have to be in it. And ideally we want to see devices in school when we're back after Easter. Okay, so I am on Zoom for your second lesson today, and if you have any questions, come and have a chat.